you have an arrow going down.
Okay.
The PCO2 is low.
Okay.
Another arrow going down, and the bicarb is new. Another
All right.
arrow going down.
Okay.
So I would say that it would be metabolic.
Okay.
But it's
So it's a metabolic what?
acidosis.
All right, so it's a metabolic acidosis, and what part of the body is trying to compensate?
Well, the kidneys are having the problem.
Right, the kidneys are having the problem, so if the kidneys are the problem, then what system has to try and compensate? The respiratory, right. And that it's trying to compensate because the PCO2 is so low, all right, which makes it more alkaline in the bloodstream, but it's not enough to bring the pH back to normal, right? Okay, so you got two arrows going down. They're both going the same direction. When they go the same direction, it's always going to be metabolic. Okay? All right, let's see. Ms. Trombu. She around? Where'd she go? Oh, there you are. Okay. Why don't you take number 5 for me? And did I pronounce your name right this time?
Yes.
All right, see? Got it. She's not alive, she's dead. All right, so number 5. Okay, and that means it's what? Is it acidotic? Okay, it's an alkalosis, all right?
The CO2 goes down.
The what?
PaCO2 goes down.
Okay, and what's the bicarb doing?
It's normal.
It's normal, right? All right, so what's the problem here, y'all? All right, y'all think so?
Yes.
Who thinks it's metabolic?
I do.
Okay, remember, what happens with when the pH goes up and the PCO2 goes down, it tells you what? When pHs and those two are going in opposite directions, it has to be respiratory. All right? So the pH is 7.48, that's alkalosis. It has to be respiratory, right?
I have my arrows now.
That's all right, Amy. Look, that's why I'm looking at the answers right here, okay? All right? So they're going in opposite directions. Now, the bicarb is normal, but what is it? Is it high normal or low normal? It's kind of high on the normal, right? All right, so this one is a confusing one because it looks like, but because the CO2 doesn't look like it's really that bad. But with the bicarbonate up at 28, it's trying to trick you into thinking it's metabolic, but it's not. You think it's butter, but it's not. It's chiffon. All right? Sorry. I know. Well, okay. I'm showing my age again, all right? I'm an old fart, All right, but my point was that because you've got the pH is elevated at 7.48, right? And the bicarb is on the upper side of normal, it makes you think it's metabolic, doesn't it? All right? But because the pH and the CO2 are in opposite directions, we already defined that as when they're opposite, they're respiratory. Okay? So it is truly a respiratory alkalosis. Who wants to do number 6? Volunteers? Crystal.
pH is a base.
Okay?
PaCO2 is lowered. Bicarb is lowered. So I have respiratory alkalosis.
Okay. And what's trying to happen?
He's trying to.
All right, Ted, say that
Well,
loud.
the kidneys are trying to compensate because they're lowering the bicarb because it's already in an alkaline state.
Right.
Is that correct?
Yep.
Okay.
Because the bicarb is dropped and it's down to 20, it's trying to force compensation. It means the kidneys have kicked in and they're trying to adjust the pH and the acid and the alkalinity to make it more acid, right? The less bicarb we have, the more acid we are, correct? Yes? Y'all with me on this? Have I lost anybody? I heard a yes somewhere. Who had it? All right, Mary, where have I lost you?
I missed the part where you figure out whether or not it's the lungs or the kidneys that are compensating.
Okay, listen to the explanation again, all right? We'll go through the whole process, all right? The pH on number 6 is the pH is 7.48. So it's doing what? What's the pH doing, Mary?
It's going up. I got
All right.
all of that.
All right, so
That's
it's going
what
up.
I said.
The PCO2 is down, right?
Got it.
So since they're at the opposites, they have to be respiratory.
Respiratory alkalosis.
Okay.
Got that.
All right, so it's an acidosis and respiratory alkalosis. I said acidosis. It's a respiratory alkalosis.
Right.
Okay. Okay. So, what else is abnormal about this? Because it's not, none of it's normal. Okay. So the bicarbonate is low.
Okay.
So if there's low bicarbonate, is that acidic or basic? Okay, so if you're dealing with an alkalosis, all right, and the body's already trying to blow off all this carbon dioxide, right? Then how else can the body compensate for an alkalosis? Huh? From the kidneys. Right, it's either by retaining or blowing off CO2 or by the kidneys. So what's happening here is the bicarbonate level is dropping. So instead of it being alkaline, it's getting more acidic. All right, and because it's getting acidic, it's trying to fix the acid-base balance. All right, so you know the basic problem because those two are going in opposite directions, the respiratory part of it, but then the bicarbonate level dropped too, which means the kidneys are trying to kick in and get rid of excess bicarbonate to make the blood more acidic. And that's how it's trying to compensate. Did it succeed? No, it did not, because what didn't happen? The pH is not normal. It's still, it could, yes.
Are you peeing it out?
Yeah. Yeah. There's an equation called the Henderson-Hasselbalch equation. Okay? It's called the Henderson-Hasselbalch equation. And it's the dissociative balance between sodium bicarbonate, carbonic acid, and limestone. Okay? I'm just saying, that's what's happening, is the body's trying to balance that equation. And so if it gets rid of bicarbonate, or if CO2 drops down, and it still can't pull the pH normal, then it starts getting rid of bicarbonate ions. And that causes hydrogen ion to rise. Correct.
About 20 to 1%.
Yes, there is a ratio of 20 bicarbonates to 1 acid. Okay? So that's basically what it's trying to do. By getting rid of bicarbonate, it allows hydrogen ion to accumulate. And hydrogen ion is an acid. Okay? That's why the scientific formula for sodium bicarbonate is NaHCO3-. Okay? That's sodium bicarbonate.